All right, ladies and gentlemen, welcome back to another math video. Today we're going to be talking about polynomial division. Hopefully it makes sense. We talked about adding polynomials, then along with adding, we did subtraction, and then we multiplied some polynomials. So now we're going to divide them. Okay? So, for example, just a quick refresher, let's talk about how to divide just in general. So let's say we took the number, let's say 7, and we wanted to take 7 and divide that number into some other number. Let's say that number is 68932. Okay, so we have 68,932 divided by 7. Okay, so we're going to be asking ourselves, what number would we multiply 7 by to get to a number that is a little bit smaller than 6, or that is closer to 6? Well, we can't do that. There's no number that will do that. So we would leave that space blank. So then we would say, all right, well, what about 68? What times 7 will give us a number that's very close to, but not bigger than 68? Well, that would be the number 9. 9 times 7. And once we have that, we would say, all right, I picked 9. 9 times 7 gets us close to 68, but doesn't go over. So we would then take and multiply. 9 times 7 gives us 63. And then we would take and subtract these two. 68 minus 63 would be, let's see, 68 minus 63 is going to be 5. Then we'll take this next digit, and we'll bring this next digit down, and say, okay, what times 7 goes nicely into 59? What times 7 goes nicely into 59 without being too big? So we're going to say, all right, that number would be 8. 8 times 7 is 56. 8 times 7 is 56. So we then would take 59 minus 56, and we'd say, all right, well, that's going to be 4. That's completely a lie. I lied to you just now. 59 minus 56 is going to be 3. We bring down our 3. So then 7 times what is going to go nicely into 33? That is going to be 4. 4 times 7 gives us 28. 33 minus 28 is going to be 5. We bring down our 2. What times 7 goes into 52? Well, that's going to be 7 times 7, which is going to be 49. 52 minus 49 is going to be 3. Since there's nothing left to bring down, we could put a decimal here and bring down a 0, but let's go ahead and just stick with a little bit more straightforward thing. So it's 9847 remainder 3. Okay? So if we wanted to check our answer, we would take this part times this part, and then we would add the remainder. So if we took 9,847 times 7, 7 times 7 is 49. 7 times 4 is 28, plus 4 is 32. 7 times 8 is 56, plus 3 is 59. 7 times 9 is 63, plus 5 is 68. So then we have 68929, and then if we add our remainder, 3, 9 plus 3 is 12. 1 plus 2 is 3, 9, 8, 6. And hey, look, we got our original number. Okay? Polynomial division, believe it or not, way, 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 way easier. All right? So let's take a look at how we do that. Okay? Let's take a look at a division problem that says we want to divide. We want to say 4x squared plus 3x cubed plus 10. And we want to divide that by x minus 2. Okay, so things to be aware of. Whatever comes, if we're writing it like this, whatever comes after the divided by sign, is the thing that goes outside, is the thing that you are dividing by. All right, so x minus 2. And whenever we're writing whatever is going to go underneath our division bar, underneath our division thing, we want to write that in standard form. All right, so 3x cubed plus 4x squared plus 10. We also want to make sure that whenever we have a gap here, like if we take a look at our exponents, it goes 3 and 2, and we don't have a to the first power exponent, we want to make sure we have a placeholder for that. So plus 0x. Okay? We want to make sure that we have a placeholder for anything that might be missing. Okay? From our polynomials. So we have x minus 2, and we're going to say that's 3x cubed plus 4x squared plus 0x plus 10. Okay? So now is the quote-unquote the tricky part, but hopefully it'll feel a little bit better than before. What we're going to do is we're going to pretend like this part, this minus 2 part, doesn't actually even exist. Okay, we're going to pretend that that doesn't exist, and we're going to look just at the x. All right, so we're going to say, all right, if I look at x, x times what is going to give me 3x cubed? X times what is going to give me 3x cubed? Well, if I take 3x squared times x, that's going to give me 3x cubed. So let's use that. So when we figure out what number we're multiplying by, then we take that number and multiply it by our x to give us 3x cubed, and we multiply it by our negative 2. This is where the negative 2 comes back. So it can't like completely go away, but it will be part of our problem. So then we take 3x squared minus 2 times negative 2, and we get negative 6x squared. Okay? So now, just like with the regular numbers, we're going to subtract this entire row. Okay? So 3x cubed minus 3x cubed is going to be 0. That should always happen. We should always get a 0 with our first term. 4x squared minus negative 6x squared is going to be, it's like if we're adding, right? Subtracting a negative is like we're adding, so it's going to be 10x squared. And then we bring down our next term, plus 0x. All right, so now we want to say, all right, x times what is going to give us 10x squared? X times what is going to give us 10x squared? Well, that's going to be positive 10x. 10x times x gives us 10x squared. 10x times negative 2 would be negative 20x. And again, we're going to subtract this from the line above. 10x squared minus 10x squared is going to be 0. And then 0x minus negative 20x is going to be positive 20x's. We then bring down our 10, so plus 10. So now we need to multiply x by something that's going to get us to equal 20x. That is going to be x plus 20. It's going to be positive 20. If we needed a negative number, we would just put a negative sign here. But so far, everything has been positive. 20 times x is going to be 20x. 20 times negative 2 is going to be negative 40. And then we're going to subtract this part again. 20x minus 20x is going to be 0. 10 minus negative 40 is going to be like 10 plus 40, so that is 50. And since there's nothing left to bring down over here, that is our remainder. Remainder 50. So again, if we wanted to check our answer, we could. All we would have to do is multiply this part times this part, and then once we're done, add this part. And that would look like this. Let's see, x minus 2 times 3x squared plus 10x plus 20 plus 50. So then we'll distribute for days. X times x squared, x times 10x, and x times 20. So that's going to be 3x cubed plus 10x squared plus 20x. We take this negative 2 and distribute it. We get minus 6x squared minus 20x minus 60. And then this plus 50 is along for the ride, so plus 50. So now we're going to combine like terms. My x cubed terms is going to be 3x cubed, 10x squared, and negative 6x squared is going to be 4x squared. That's going to be positive. Just x terms, 20x's, and then subtract 20x's is going to be 0x's. So those effectively cancel out. And then if I take my constant terms, I have 60 and 50. So that's going to give us negative 60 plus 50 is going to give us negative. Hang on one second. Okay, I see what I did. I make it a mistake. This should not be 60. This should be negative 40. Whoopsie daisies. 20 times 20 is not 60. Or 2 times 20 is not 60. 2 times 20 is most times going to be negative 40. My bad. So negative 40 plus 50 is going to be positive 10. So this, if we re-expand or check our answer, this guy right here looks a whole lot like this guy. Okay? Nice way to check your answer. All right? So with that, that's all you need for the lesson today. I'm gonna do one more example if you want to watch and follow along and try on your own. But you are welcome to stop now, go take a look at the lesson, and or go take a look at the homework and try that on your own. But so I'll pause now for those of you who are trying to do that. All right. So let's take a look and see what happens if we're not dividing by just like x. If we're not dividing by like x plus 3 or something like that. If we're not just dividing by a linear thing. All right. The rules are still the same. So let's say we have y to the fourth plus 9y plus 20. And we want to divide that by y squared plus 4. Okay? Let's see. Sorry, this is 9y squared as well. So if we want to divide that by not y squared plus 4, what would that look like? All right, so again, we set up our division problem, but before we do, let's go ahead and put in all of our placeholders and let's put everything in standard form. So we have y to the fourth. Since we don't have a y cubed term, we need plus 0y cubes. And we don't have a 9, we do have a y squared term, so plus 9y squared. We don't have a just y term, so plus 0y plus 20. And then we need to do the same thing for our for the thing we're dividing by. So that's y squared plus 0y plus 4. Okay? So now we set up our division problem where we have y squared plus 0y plus 4 divided into y to the fourth plus 0y cubed plus 9y squared plus 0y plus 20. The rules don't change. We're always only ever going to look at this very first term, and we're going to ask what can we multiply this first term by to match up with these the other terms that will be showing up. Okay, so what can we multiply y squared by to get to y to the fourth? Well, that's going to be y squared again. Y squared. So then we take y squared and distribute it into all of these other three terms. Okay? So y squared times y squared is going to be y to the fourth. Y squared times 0y is going to be plus 0y cubed. Y squared times 4 is going to be plus 4y squared. And again, we're going to subtract this entire parentheses. So y to the fourth times y to the fourth is going to be, or minus y to the fourth is going to be 0. 0y cubed minus 0y cubed is going to be 0. 9y squared minus positive 4y. So 9y squared minus 4y is going to be 5y squared. All right. In the last example, these numbers we added them, but this guy right here was always a minus sign in those last ones. Okay. So be incredibly careful when you're trying to do these guys. When you're trying to work through these guys, keeping track of your subtraction. All right, 9y squared minus 4y squared is going to be 5y squared. We bring down our next term, which is 0y. Okay, and we also bring down our 20 term because we have 3 terms here, so we need to bring down 3 terms. So plus 20. So y squared, and then something times y squared is going to be 5y squared. So something times y squared is going to be 5 times y squared. 5 times y squared is going to be 5y squared. 5 times 0y is going to be 0y. And then 5 times 4 is going to be 20. So 5y squared plus 0y plus 20, we're going to subtract that from 5y squared plus 0y plus 20, and we're going to get 0. So our remainder for this one is going to be 0, which is really nice. That has a special meaning that we will talk about in the future. But pay attention and see if you can look for zeros, remainder zeros. Remainder zero is a huge thing. Okay. Again, let's check our work. So if we take y squared plus 5 and multiply that by y squared plus 4, and then we add 0 to it, so I'm just not going to write it down. But if we multiply these two things together, we get y squared times y squared is y to the fourth. Y squared times 4 is plus 4y. And then 5 times y squared is plus 5y. Sorry, I left off the squareds. 5y squared. 5 times 4 is 20, so plus 20. So we have y to the fourth. These two add together to make 9y squared plus 20. Okay? And that looks a whole lot like that. 9y to the fourth plus 9y squared plus 20. Okay? Again, the entire process, we are always going to be taking our first term and saying, what do I multiply that by to get to my first term here? What do I multiply this by to get to our first term? What do I multiply this by to get to our first term? Every single time. Okay? All right. If you have any questions, I'll be live every day at 1 o'clock to help you out. All right? So with that, I hope you have a wonderful day. I will see you guys hopefully sooner than later. Bye. Talk to you later.